still going to give him 20 minutes. This is Dan Hanlon from UCL. He's going to do a lot of typing on the screen and talk about using iRODS as a presentation layer for research data storage at UCL.
Thanks very much, Terrell. So I'm going for the prize for the glitziest PowerPoint, as you can imagine. I actually even have color in here. So I hope that's readable. It's difficult to work out what size ASCII text is going to appear when it's projected like that. Anyway, so yeah, I'm Daniel Hanlon from University College London. I work in the Research Data Services team, and I'm going to talk a little bit about what we do. Also then describe our iRODS infrastructure. I wouldn't be here otherwise. And then talk, rather than sort of have a sort of big bang, this is the new thing we've done. I was really just going to describe various little things that we've come across during the time when we've been building our iRODS infrastructure, approaches we've taken, and how we've put it all to work, really. And I'm, as much as anything else, interested to get negative feedback if people think this is a silly way of doing it. And maybe it's that we've missed something that is part of the iRODS world, but just something I haven't come across. So in general, the two areas that we've sort of been working on that are a little bit out of the ordinary are our approaches to authentication, then cache management. We use a compound resource, and then we've got various little utilities that we've developed along the way. So I thought I'd show you some of those, and they're all on GitHub, so you can look at them. There are links later. So Research Data Services at UCL is part of the central IT department. So there's an Information Services division, and within that we have a part that's focused on research activities. And we have a research computing bit that does high-performance computing, software development bit that does that, and we're the data bit. So we are tasked with providing storage for research, not for business activities other than research, for the whole of the university, all the schools, all the faculties, all the departments. And I don't know the exact number, but I think there's between 5,000 and 10,000 active researchers at UCL, sort of people who are receiving grants. And each of those is eligible to use our storage, plus, of course, all of the PhD students and RAs or whatever associated with them. The reason that this is all funded centrally is because of a recognition within the university that data management is becoming an increasing burden for researchers. Not that long ago, a relatively small proportion of the research community had to deal with big computers. Everyone else could get by with relatively normal PCs, and the volumes of data involved were very manageable and didn't require that much special effort. So we've got people who've grown from that situation, but not in a particularly controlled way. So we've got lots of USB hard drives all over the place. We've got people using Dropbox because it's safe, they think, or there's people essentially doing data management without any real thought about how it works, and not sort of considering other uses the data might be put to. So reuse of old data and sharing of new data are big drivers too. We are very much a multidisciplinary institution. It's been around for a long time, so there's quite a lot of data that's produced by different groups, and then subsequently other researchers might want to use that data again, but at the moment it essentially gets lost because it's not being managed. And the final compliance issue is around various funders are starting to have requirements as to how data is managed, and part of the role of the Research Data Services is to help people with that. So in particular, the iRODS component is part of a research data storage service, so the simplest bit of this in a way. And so what we do is we provide data storage for funded PIs. The idea is this isn't a home directory, this isn't somewhere for them to store their own stuff, it's for the group working on a particular project to share data. It's safe, it's in a centrally managed resource. We give them 10 terabytes, I say 5 because it used to be 5 terabytes, but we, being more and more generous all the time, we give them 10 terabytes each. and they can apply for as many projects as they want, so it's actually a relatively generous allocation. All we say is that it has to be time limited, so we won't guarantee to look after this stuff forever. We need to know when it's going to be, when the project's finishing, and it can't be more than 5 years from the start date. So at the moment, we've actually got a couple of types of storage. We've got a large, well, it depends on your scale, but we've got a couple of petabytes of GPFS and a couple of petabytes of DDNs WAS, and the GPFS is presented as a conventional file system, and the WAS is presented via iRODS. And just in the iRODS component, we've got just over 200 projects, which is 635 users as of today, and 30 million objects and about a third of a petabyte. Now, these are strange numbers. We actually did a major system upgrade last week, and in the last week, we are ingesting 2 terabytes a day. That's not been our normal rate of ingest at all, and 100,000 objects. But that is what's been happening since last Thursday, and the system seems to be managing. So, but we'll be a bit worried if that carries on indefinitely. So, as I mentioned, our iRODS infrastructure is backed. Its storage layer is DDN's WAS object store. We've got a couple of petabytes of that, and we use their distributed erasure coding, their global object assure policy. So we have 3 logical zones that represent physical boxes, and each object is chopped up and distributed around these 3 zones so that we can lose one of them and the object can be successfully recovered. The iRODS side of thing is relatively simple, really. It's just a single ICAT server which acts as the cache resource for the object store, and we have a pair of pgpool2 Postgres databases separately. From a middleware perspective, it's just one zone, and this is as I described, you see my cursor now, it's a simple compound resource with the WAS archive at the back and the ICAT server providing the cache. Because we allocate storage for projects, we don't use home directories, and that has caused a few problems actually at times. There's a lot of bits of infrastructure that work with iRODS assume that people have a home directory, and we don't give them home directories, so things can go wrong. So things like we often get strange errors where there are someone's tried to create a bundle and a file has appeared that actually doesn't have a directory to go into, but it's sort of sitting there as an orphan within iRODS. So that's something that's been a bit strange. The interfaces primarily used are the iCommands are the ones we recommend really for those who are happy with the iCommands. And CyberDuck is probably the most widely used interface. We've got quite a lot of people who are a bit scared of the command line. And we also have effectively a pilot of DAVRODS, not because we have any particular worries about it, but it's just not been promoted particularly, and then there's plenty of issues with getting people up to speed with the other interfaces, so that one tends to come last, especially in the context of people often using iRODS for large files, and there are issues with very large files with WebDAV. So the way, when people register for the service, we auto-generate for them an iRODS environment.json and a rds.cyberduck profile for CyberDuck, and that gets sent to them in an email so they can get going relatively easily. And they log on with a PAM authentication, but it's actually a slightly odd variant on normal PAM authentication. So effectively, probably many of you know this already, but the PAM authentication essentially works by just creating a TLS tunnel, sending the credentials down it, and then running a little binary that sits within a server bin called PAM auth check. And as long as you send the password to standard in and pass the username you want to authenticate as a parameter to it, if it returns successfully, you're in. If it doesn't, you're out. So you can very easily just replace that with whatever you want to do. So we actually just have a little a script. This is a a little JavaScript example. We actually have a Perl example, but it means that we can really trivially look at the username that people are logging in with and decide how we want to authenticate them. So we say, oh, this is a typical UCL person. We'll just do a Kerberos lookup. Or if it's an email address, we can go back to native authentication. So it gives us quite a lot of flexibility, and it's just extremely easy to use. So the other part of our infrastructure that's perhaps a little different from other places is our cache management. So we have quite a lot of WAS, and really we have a goal of wanting to get data into WAS as quickly as possible and clear the cache. In the first instance, we didn't actually have that much cache disk, so part of it was that we just didn't want it to fill up. But the primary drive really was that WAS is giving us this geographical resiliency, and we're telling the researchers that if they store data with us, they're going to have effectively 3 copies and blah, blah, blah. And ideally, when they've finished writing their file, if it's completed successfully, we'd like that to be true. So we really want that to be the case. We use SHA-256 checksums all along, and essentially have implemented cache management policies based on looking at these checksums and making, hopefully, the right decisions. So the checksums are generated in AC postproc for put in a relatively standard way. So essentially, there's a trim rule that we have, which in sort of pseudocode, it has as an input a data ID, so a file that's in the cache. Sometimes, say the checksums failed, it will checksum it if it's not already been checksummed. Then it will, with the integrated query, it will look for any replicas that exist in the cache of the same object, do a comparison of the checksums, and then if the file's new, it trims the, if the checksums are identical, there's no point having the cache copy because it's just the same as what's already there. We get an enormous number of people who write files that are identical to what's already in there. I think it's just they're being ever so safe about things, so they think let's just store it again, and that happens a lot actually. So in that case, they don't realize, but all we do is just say, oh, that's the same as what we've already got, and we'll trim the cache copy. Otherwise, we trim the archive copy, and the next time this is running repeatedly, and the next time it runs around, it will then come across with no archive copy, so the other side of the if statement gets executed and it gets copied to the archive. So this is a rule that operates on an individual object in iRODS, and so we have again, it's very, very simple, all of this. We have a bash script that essentially repeatedly queries the cache area of the disk with a normal Unix find. We work out the data ID with an iQuest. First thing actually was it would check whether the file's open, because if the file's open, it's probably still being written or being read, or to be a bit careful. But if it's not open, we get the ID and then we pass that to the rule, and just carry on doing this and wait 300 seconds. It's just a very simple loop, telling the person watching it what's going on. Either we can log somewhere, or I've got it actually running at the moment in a TMUX session, so all being well, if eduroam doesn't go down on me, we'll be able to see it. So before we do that, I mentioned there are a few little other utilities we've done. So in the process of looking at how we interact with WAS and how WAS and iRODS can work together, we've got some little utilities. So we've got a little binary that takes an object's ID from WAS and returns the iRODS format SHA-256. Similarly, the SHA-256 sum is a quite useful utility, because telling people that they've got to do base64 encoding and blah, 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 the average Windows user hasn't a clue what any of that means. So we can just give, there's a C++ version and a Go version that you can build for Windows, and they can run it, and even a GUI version, which is which is helpful for people just to check that the file's gone in properly. And also, these are little silly tools, iVi, ilocate, icat, there were a number of Unix commands that I used a lot that didn't have an I version, so it was easy enough to hack one together. So if all things are working, so this is the sort of live feed of our system, of the cache management side of things. So at the moment it's sitting there. Okay, thank you. Yeah, so I think Tmux has slightly messed up the display, but this is currently sitting there waiting because there's nothing much going on at the moment. But that is now triggered a run, so it's gone through. So essentially, the things that are showing up in yellow are files that have been noticed as needing processing, so to be moved into the archive or cache trimmed. Files that show up in red are what those are to open. And you can see it gets to the stage where it's there are only open files, so it stops and has a rest. So if we can try and demonstrate this working. So, so we have a file called.re here in a empty collection in iRODS. So if I put that into iRODS, shouldn't take that long. We can see that you can just about manage with the corrupted screen that it's sitting in cache and in the archive. But if I trigger that rule to run, it's gone off and done the others, and at the bottom there, well, the second yellow one up from that list is quad.re, and you can see it's just sitting in the archive now. Just as an example of the other silly little tools, if we were to edit that, you can edit it with iVi and add something. So that will write it back in again. And so we see we've got the cache copy again. The rule's asleep at this point because there's so little happening. But again, if we run it, it will catch it up, and we see we've just got the archive copy again. So it's relatively effective at if simple, at keeping the cache more or less empty, yeah, it's not quite as connected to the user as we'd originally wanted. So as I was saying, we'd like a situation where when the file is finished writing, it's gone straight into WAS. This isn't the case at the moment. We have tried with that. So I'll go on to the rest of the presentation and explain. So this is the end now, really. But these are things that we're working on at the moment. So for want of a better description, inline cache management. This would be something that we have had some of this rule running inside AC proc for put, and it has worked in some situations, but there have been problems. So that's not the current live system, but that does give you the functionality we wanted. So we have a situation then where there's a pause at the end of the iPut or your cyberduck write, but that pause is first a checksum and then they move to WAS, and then it just deletes the cache copy straight away. Another aspect of this is taking that WAS object ID to SHA-256 code and wrapping it into a microservice. So the idea here is that we would like to build a system that as a background task effectively performs something like a scrub that's looking through WAS, checking that everything still has the checksum that it was supposed to have. So this is useful because it actually calculates it on the fly, so you don't actually need to pull the object back to cache. If you call this microservice, it will just return it pulls the file back, but it doesn't actually write it to disk, and just works out the hash and lets you compare it. sort of tied into this is there's a microservices meta modifier that lets you change certain aspects of an object, but doesn't let you set the date or a date stamp effectively at the moment. And that would be quite a good way of making the trim cache functionality even better. So if we've got somebody writing a new file into cache that's identical to the old one, in many ways, it would be nice to be able to change the date stamp so that we recognize this has been written now, even if it's the same. And you can't do that at the moment without deleting the archive and rewriting. Also, other things we've been looking at are iCommands on Windows. I think we mentioned yesterday that actually the latest version of Windows, Windows 10, if you enable the Linux subsystem, whatever it's called, is effectively a full Ubuntu. And you can just install the iCommands, and they work perfectly there. And we've got a few people using Windows quite successfully in such a way that we have a virtual machine, or we could probably do it with Docker as well, running the iCommands and mounting a bit of the Windows file system so that a cron job can be running, sending data into iRODS. Other more distant ideas we've looked at a little bit are using the fact that an object store is, in a sense, there's no point having an object store without any empty space, because as it fills up, you don't really have any performance implications. So when people delete things, it would be quite nice if the WAS driver didn't actually delete them from WAS. This is the new version. There'll be a new version that will be returned to the user, but effectively building something a versioning system that would keep track of the old versions that still exist in WAS, so that as something towards part of what people mean by backup could be achieved using that. And finally, the checksum utility that I mentioned, a GUI tool that we have, is part of an idea to build something that helps people to have some confidence that they've uploaded a data set to iRODS successfully. We have quite a lot of people who will get, a hard drive will come in the post from the BGI or somewhere, and they're desperate to make sure they've got a safe copy of it. And if they can generate checksums locally, and then with some sort of simple tool see that it matches with what's been uploaded, they'll be quite happy with that. Thank you very much for listening. I don't know if there are any questions, or if there's time for questions.
There is a question cube somewhere. It's over there. He has a question. After the questions, we have a quick sponsor talk from David Paredes at DDN.
That's good timing.
So if there's a question, now is your moment.
I could ask a question, if no one else. Without downplaying whatever you've created, I think it's very nice. But essentially, it's a front end to an object store for users. Correct?
Yeah, but I'm guessing your question is why bother? Why?
No, I'm not getting at that. My question would be, are you planning on adding any features that would also make use of the capabilities of iRODS to add metadata? And
yeah, absolutely. I mean, the rationale is that we don't have any sticks, we only have carrots in this sort of game with research data management. And if we can provide a system that is sufficiently simple to use for people, that they start using it, at this point they're not even vaguely interested in any of the other facilities, then we're in a situation when we can help to encourage people to use the other facilities without a big sort of hurdle of having to shift onto a different infrastructure. So that's where we're coming from, really, that we'll be able to go to people and say, oh, that iRODS thing that you're using and you're happy with, we hope. By the way, you could be storing metadata there. You could be using more sensible ways of structuring your data rather than just very long file names. You could be working out which files came from that particular job run by having a metadata field associated with it. So we can sort of encourage that, and I see it as essentially providing a lot of hooks that will enable us in the future to encourage people to manage their data in a more sensible way.
Thank you. Interesting.
Okay, so we have one quick, short, maybe long, I don't know. This is from our gold sponsor, DDN. So.